The Harman Kardon 305 amplifier, I have a problem in the right channel before. I fixed it, and after I fixed it, I put it in the reliability testing. I run in full power for a couple of days, and then it faded. And this time it faded on the left channel. Usually, I see one of the resistor to my speaker, series to the speaker. So if I got high voltage DC applied to the speaker, and this resistor will take majority of the voltage, so the speaker get protected. But this resistor has to be big, because if you put a 1/4 watts resistor here, it's going to be bent down very quick. I got 6 things, 5 watt. Let me short circuit this resistor to see how severe the amplifier can get damage to this speaker. I will have put my hand here to be quickly turn it off. The speaker sink almost a ½ inch. You know, in the old amplifier, the vintage amplifier, usually the amplifier only got the, you see it over here, this fuse, only got 2 fuse connect series to the speaker and the output of the amplifier. This is a thing to protect the your speaker. As we know, the modern speaker, good speaker, is much expensive than the amplifier itself. So if you don't have the protection to your speaker, once the amplifier fail, they apply like very high DC voltage to the speaker connector, it's gonna kill your speaker. Even though the speakers be able to hold on, but it might get severe damage. I do a quick test to see what happened to the amplifier. It pushed the speaker very bad. We got negative 24 volt on the speaker. It's supposed to be 0. But we got negative 24 volt to the speaker. DC. That's very bad. Let's go back to the schematic of the 305i. This is the main power output section. This 2 transistor is the main power output transistor. The connection from the from the main power transistor to the speaker is direct connect. Sure, there is a fuse over here, but we know fuse will act time is much slow. If you got very big circuit from like this floor, before the fuse got blown up, the speaker already suffered a lot of damage. compared to the direct connect, there is also a common, let me move it up a little bit. Yeah, there is a very common the circuit used in the amplifier in the early 80 or late 70. This amplifier, this is the power transistor, this two. There is a capacitor here. This capacitor is 4700 microfarad, 63 volt. The signal will pass through the capacitor to the speaker. So when these two things fail, it doesn't matter how high the voltage you pass to here, because this is a capacitor. The DC won't be able to pass here, so the speaker is safe. We call this kind of a circuit we call OTL, and the direct connection one we call OCL. So in the 80s, when we work in the amplifier, there is a lot of article talking about what capacitor you should select to using as a output couple capacitor. Course in the modern market, this thing itself will cost half the price of the whole amplifier. If you want to make this thing very good, like if you want to make your amplifier can be able to handle lower than 20 Hz and can be able to handle up to 16K Hz, and also you want to make the frequency response flat all the way from the 10 Hz all the way to 16 Hz. This thing is very, very difficult to find, and you don't know. It got aging also. So the thing is what? After the 80, I think the middle 80, majority of the amplifier, it switched to the OCL thing called direct connection. See, over here, you don't have the capacitor. And the thing is direct connect to the speaker. So you get rid of the complicated stuff over here, and you reduce the price also. We are facing right now. If you got something over here and the speaker got blown up, and speaker, if you want to talk anything about hi-fi audio, first thing the people suggestion to you is what? Get a good pair of the speaker. Put your 50% or more than 50% of your money in the speaker, and the rest of them take the other 50% or less than 50%. Because speaker is the most difficult part to make it frequency response very flat or whatever. If you want to have a good pair speaker, it's much difficult than the electronic. Then by that of the situation, you got a fuse about like 1 or 2 cents for a piece of the fuse to protect your very lovely speaker. And then at that time, a lot of people can be hesitant. Say, do I need to using this kind of the vintage amplifier? Only because this, a lot of people was hesitating. And then the other problem is what? The amplifier, when you turn on the power switch, this capacitor, they might not 100% have the same parameter from all the way to here to there. So before the power get balanced, there is a slightly voltage here, and that's what we hear the speaker when you work in the vintage amplifier. When you push on the speaker, the power, and the speaker have a sound pop. When you turn off the amplifier, you also hear another sound pop. It the speaker get the unbalanced value voltage here to push it. Because the direct connect power amplifier have that kind of the risk of the to the speaker, so the later amplifier majority of the we cannot say high end, that anything like have over 50 watt or 30 watt, that kind of amplifier, majority of them introduce the speaker protection to the circuit. What is speaker protection? See, this is a very typical protection. I got this thing. This is one of my amplifier. It's a NAT 7400 amplifier. It's about I think it's over 80 watt. That's the amplifier. In this amplifier, so this thing is a power output. Let me see. Yeah, that is the power output transistor. In the NAT, the speaker channel is come from here all the way to here, and then there's a 56K resistor over here, send the signal to this IC003. What is this IC003? It's a UPC1237 UPC1237 IC003. What this thing doing? This thing pick a piece of a signal from this R037 56K, feed to the pin 2 of the IC. And there is another one, R038, also 56K, pick the signal from the other channel, because we know stereo is have two channels, right? So this one from here and the other one from here mixed together over here, push to here. And then from this output, they have a 6 pin go up to connect relay, and that relay will control the speaker to be able to let me go up a little bit. Yep, over here. The speaker, see the L and R, will be connected by this relay 002, RY002 over here, this relay. So when anything happens to this two resistor, it push very higher DC to this IC, and this thing cut off the relay, cut off this relay, and this thing is just open. Because this is electronic control, the reaction time is much shorter than the something called physical fuse. So that give a good protection to the speaker. You also get a delay to turn on the speaker. Over here there is a capacitor. I think it's number 7 over here, this one. The pin 7, there is a capacitor over here. You see there is a resistor over here, 56K. When the power provide to this thing, this is RC circuit. When we know RC circuit is what? the capacitor voltage build up slowly by this resistor charge it. So when the power just turn on, this thing is 0 to ground. This thing is 0 to ground. And this 7 pin can control this 6 to cut off the speaker. Until this thing got charged, it take about 5 seconds to this thing charge to the voltage of the provider power. And this thing turn on number 6. So this thing close. The speaker will connect to the power amplifier. And when you turn off the amplifier, because you turn off the amplifier, and immediately this thing will cut off the speaker. So even though there is a remain charge in the big field capacitor in the power amplifier, and you will have some unbalance, will have something will feed to the speaker. But because this thing cut off the relay immediately, so even though the remain voltage in the amplifier still feed to the speaker, but this thing already off, so the speaker will be. You will not have the thing like you push on your amplifier, you have a pop, and you push it off your speaker, your amplifier, you have a pop. So this circuit actually doing 3 things. One is protect the failure of the circuit. The second thing is delay and immediately cut off the speaker when the amplifier is turn on and turn off. I actually have 2 of this kind of module. I got it from the internet. I think it's from eBay. I have nothing to do with those manufacturers or this company. I just bought them to add to my vintage amplifier. I have used this module to my Sanyo 30-watt amplifier and to my Sansui R50 and also to my NET 710. Yeah, all good. And this is another module, another model. Why I bought this one? This one is about $20. This one is about $7 per piece. The IC over here, they're the same. It's UPC1237. It's the same. The circuit over here, almost the same. The connection are the same. The provider voltage to the unit is similar. Only thing here different is the relay. The relay. This one is something I believe is more better quality than this. If we see the connection, see that the connection over here, it gives me some of the confidence of the because when we're talking about we have power output from the transistor to speaker, we may have 100 watt to that. If you get a very low frequency like the drum, and all of a sudden you have a symphony, every instrument playing at the same time, so you get a very big current through the connection of the relay, and this one give me something called confidence. Now let's take a look at that UPC. What is doing in that speaker protect circuit. The UPC1237 number 6 is the one who driven the relay. So this guy is the one who do the actual work to protect the speaker, delay the speaker, turn on, and quick start of the speaker is number 6. And number 8 is the power input. And number 7 is the RC circuit here, RC circuit. There is a 33 mu. I'm not sure in the actual module I have how many megafarad it is, but this two things control the time delay for the number 6 to turn on. When you first turn off the speaker, the power amplifier 45 volt, I'm not sure the 45 volt what voltage it applies to here, and then this RC this resistor will charge the capacitor until this thing rise to a certain voltage. The 7 driven the 6 to turn on the relay. And this number 2 is the one, you see that 2 or 3, it connects to 2 of the speaker output. And this thing, if this thing detect to a very higher voltage or something, this IC thing it's not normal, it can cut off the 6, cut off this number 6. So to protect the speaker, connect to the relay. And this is actually the thing how it connects to the circuit. This is the left or right channel of the power amplifier. This is LH, this is RH, right? And these two things connect to a 56 k ohm resistor. And then these two resistors pass to the number 2, the pin 2 to the UPC1237. This pin 2, if it's abnormal, if it's out of the range or something, it cut off the number 6. The number 6 is driven the relay over here. The relay control the speaker. It's connect to the circuit or out of the circuit. So this is pretty simple the connection. The real connector it is similar to this thing. The voltage you feed into the unit, don't touch the AC thing. You should use the DC. And the L in is from the amplifier. From the amplifier connect to L in, and then the L out connect to your speaker. And this is the amplifier. See, the out connect to the in, and the speaker come back to the ground. Same thing for the R in to here, and R out to the amplifier. Now with the speaker A connect to my from my front panel. This is speaker A. Let's see which one connect to which one. So this A supposed to be here, and connect to the other one. It's not working. So this left channel is over here. So we can see the left channel is this side, and the right channel is this side. And also, there is an output over here. Let me see which one. See this one? And this. And this also connect to here. This connect to here. So by this, we know this wire, this port is connect to the speaker. And let's try this one. You see, we don't have the connection here. But if I also enable the speaker B, see that? Disable the speaker B. Now it disconnect. Now connect to the speaker A. I also cut off the speaker A. See that? Now we know this is the output pin. Now we know this and this is the amplifier output we needed to connect to our module. And this connect to over here, this one. And the other one connect to this side. One is the green line and the other one is the, I think it's purple. Yeah, the color is purple. So now this two is the one we want to connect to the module. We want to disconnect this thing to the switch, and then the switch will switch to either the A speaker or the B speaker, or both A and B are using. So we want to connect the module to here to be just cut off. It doesn't matter you switch to which speaker. Let's see what is the main power voltage we have in this amplifier. I know the main power supply direct connect to the power transistor C pin. Let's try over here. $31 negative. So the other one we're gonna be the 31 positive. So we got the 31 volt of the main power supply. It's kind of a little higher than the module can handle. It marked as like 12 volt to 24 volt. Then we cannot direct connect to that. One way we can do that is using a resistor to lower the voltage, because this thing, it doesn't need a very stable voltage to that. So we can see the I don't know what is the capacitance for the voltage for the resistor yet. We can make a test to get that. The other way we can do is we go to the diagram to see. So this is the diagram we have. We know the main power supply over here. These two, negative and positive. This negative, this positive. We measure is 31 volt there. A little higher than the module. So we don't want to connect to that because it might burn that thing down. There is another thing over here, Q2. It provides 14 volt. 14 volt to the outside. If we connect that module to here, it will be right in the range of the injection of the module. We will try that. So let's stick to this power to see do we be able to use it. This Q2, we know something over here is a very small resistor to drop the power, to drop the voltage, to provide to this transistor. There is a dial here to control the voltage. It's 14.7 volt. Now because there is 0.6 volt over here, so you got 14 volt out here. Even though this area have a little bit fluctuation, because this is the dial, they have 14 volt stabilized here. So you will keep this one is 14 volt. And this 14 volt gonna provide up to here to give to something else. See that? Give to this one. What is that? It's just the power indication, power output indication, or all kind of the LED display on the front panel. I don't quite worry about that. If those things got a little bit dim or a little bit brighter, I don't think that's a big deal to me. And the most important is we need to see this thing also provide the who else. Yeah, you're actually going up to the flange for this section. It's also connect to the radio. Okay, it also provide for the radio section. Is that gonna cause any issue? I don't know until I try. But based on the voltage I have over here, it's good to me. So I go ahead to try to using the 14 volt from here to connect to the module, and then see if that have issue or not. If it doesn't have issue, it's good. If it has issue, make the it gonna be about 200 hertz to 300 hertz, that kind of a hum. If you have the hum, then I will do the resistor, drop the main. I will do the resistor, drop the main power supply voltage from here to get it. This is the safest way to do that. There is a very, very important topic we need to talk about here. What? Because this module, it will connect to the power output of the amplifier, and this ground will connect to the power output section of the amplifier's ground. Because this IC have the ground connect to this, so this ground and this ground will connect together. So this module is not totally isolated from the rest of the circuit. What that mean to us? It mean to us ground. What the ground? If anybody walk in the vehicle speaker before, you will know there's something called ground loop. What's ground loop mean? Ground loop mean your signal come into the device and the ground is not connect to the place you're supposed to connect it, and the circuit will follow from your positive lead to the device and come back from the ground lead, connect to your vehicle's chase. And if that ground connect the chase have a resistance, so there is a voltage drop there. And that voltage drop actually is similar to a signal applied to that device. It can make a humming noise, a low frequency humming noise. We come back to the amplifier, we see that Q2 actually is here. It's kind of the middle range, middle power of the transistor, because it needed to provide a lot of power for the front end. Let's go up to see. See that? It's right in display. And there is a hole over here. I will wire my stuff from the back to the front to try that. Let's try this first. There's one thing needed mention here. The amplifier is not like the modern amplifier. This wire is not short to that. It's wired to that. How do we wire that thing back again? Sure, you can go over there to use the solder to solder to there, but it doesn't look good. Let me introduce a small tool. When we work in the vintage amplifier, we needed to have that. This is a wiring tool. I can focus in the tip on the tube. It's too small over here. There's a hole over here. Yeah, we can use this thing to rewire the vintage amplifier connection. We don't need to use the solder to solder it to there. It looks ugly. Yeah, this is how it works. It has a hole in front of that. There is another hole. I'm not sure we can see that. Yeah, see? That's the hole. This big hole can put into the pole. And there is a small hole. We put that wire through that. You need to use the solid wire, not the wire like that. No, not this way. Let's see how it works. I don't have green color. I use that red color instead of that green color. The wire is through the small hole into this tool, and there is a big hole down here. The bigger hole, and that hole will run through the. See that? It runs through the pole. After that, yeah, let me focus on that. After that, you turn this thing. And the wire can get it up by the turning. I'm not sure we can see clear over that. You see, now I wired it up. So this look like the same as the vintage stuff. It's not like the new one we using solid to that. Look over here. There's a whole bunch of things like it. It looks good, look. And actually there is some introduced about that. Say, this thing actually lasts longer and more reliable than the solder because it never gets loose. Yeah. I do have multiple color solid wire. Why I don't use this? I do have the green color and the red color, blue, yellow. But to be careful, look the wire here. Look this wire. This is the original wire. It's I believe this 18 gauge to 20 gauge. The wire over here, I believe this is 22 gauge. Because we are dealing something with the final amplifier output, you don't want to use 22 gauge, 24 gauge, even like a 30 gauge wire to do the output. And same issue, if you want to wire the power amplifier, if you want to wire the big power from here to the other side, you don't want to use 22 gauge or 24 gauge. The wire, the gauge of the wire is like this. The bigger the number, the thinner the thinner the wire, the smaller the wire. We know the wire, if we want to measure how much current can through the wire, and the wire resistance is the thing. What the bigger the square of the wire, and they can pass, the bigger the current it is. So if you're doing something on the power amplifier in the final stage or in the power stage, you don't want to use the thinner wire for the power amplifier to that area. Now, wire it up. Everything's wired up. Actually, I found out the Q2 is connected to the port down here. See that? I'm not sure you can see that. It provides a 14 volt. I don't even need to start it anything through this hole to the transistor. I just need a wire to the port over there. Now it connects to this say 12 volt. Actually, I provide a 14 volt to that, and this is ground. Don't reverse it. If you reverse it, it's going to be short circuit. We'll double check it later. And the speaker connection did connect to here, did connect to here, and this wire actually connect to here, right? And the other wire, I don't have the other color. This black wire connect to this output, and this wire is the ground, connect to here. You know, the output is over here. I don't even cut it off. So this wire connect to the output, this wire connect to the output. Now, let's put a piece of cardboard on there to be not to short circuit. Now the connection is ready. Amplifier output connect to R. The left in, actually this color is reversed, right? Left in, R in, and the ground. And if this thing kick in, it's gonna connect to this out and connect to this out. And this two out goes through to the flange switch. See, that's A, that's B, right? The switch will connect to here, to the output. So now we actually add this device in between of the amplifier to the speaker. I will double check before I power it up. Before power up, always double check, and double check. I connect my black lead to ground. Now I'm grounded. Let's see my ground. It is grounded. Ground, and power ground. Make sure this 14 volt not grounded. Yeah, look good. It's not grounded, right? And make sure the speaker output is not grounded, or you're gonna kill your output transistor. Now it's okay. Okay, it's not connected to the ground. Sure, the other side is not. I have no speaker connect to the other side. I connect that to the gimbal. I don't want to make the things like burn down a whole bunch of part in my amplifier. Connect to the gimbal and then power it up to see what the gimbal doing. It looks normal. The gimbal test is okay. But remember, the amplifier is not fixed yet. There's one channel, put the negative 20 something volt to the speaker output. and that's not good. But we are using this case to test this speaker protector. If that really can be able to protect our speaker. If it's good, then we have the extra layer to protect to our vintage amplifier. We'll be able to sleep, like close our eye to sleep, right? More calmly. Blue and green LED. If this blue thing in, mean power is on. This green thing in, mean the things kick in. Let's see. Okay, now power is on. Let's wait a couple seconds to the amplifier to power up. I don't see that green thing is on. I don't see that green thing is on. Maybe something wrong. We know our left channel have problem. Let's double check it. I turn the switch on. See the blue lights on. Let's check the output. Check the right channel first. The left channel. Oh yeah. Oh, negative over 20 volt. Check the right channel. The right channel is 0.2 volt. Negative 0.2 volt. That's good. The right channel is good. Left channel, double check it again. Oh, 26.9 volt. That's overflow the 20 volt of the meter. So, see, that green light is not on. Our speaker, if we connect our speaker to that, it's safe. Okay, power it up. Let's try again. Because this amplifier is delayed about 6 seconds, I do see the smoke start jump a little bit. Yeah, let's try again. That thing makes some sense to us. Let's try it. Yep, that's the case. I didn't touch it. I didn't touch the speaker. I only turned on the power. And after 5-6 seconds, this smoothing jump. What that mean? That means something from the wire feel the speaker, and the speaker start to do something. So it shake, this thing jump. But it doesn't like the way it does before. It did before. And before, this thing just dropped like a half inch and make a lot of noise. Okay, let's go back to the theory. When we power on this thing, as we know, there's a pin 7 will be slowly charged by a resistor to delay the relay to close. Once the relay close, the signal will pass the in to out, go to the speaker, and then send to here. And when the speaker receives the signal, and this thing will jump, right? But right after that, because we know we get 26 volt over here, and this thing also feed to the IC over here, the UPC1237, and that thing immediately detect there is out of the range voltage in the speaker output. Immediately this guy cut off the pin number 6, and then disconnect this relay to this output. So the speaker have nothing showed up. Now I will take out this wire. The output of the left channel is grounded to the ground. So now, based on the knowledge of this device, it will say everything is safe. The speaker can be connected because the negative 20 volt is not provided to that. Okay, let's try. Focus on that green light to see if that green light is on. That means the device is working to kick in the relay. Let's put it in the dark to see how the green light working. Turn on. Yep, the green light is on. And we also hear the kick of the relay. So far so good. Broken amplifier provide negative 26 volt to that output, and this device actually be able to protect the speaker when the voltage rise to more than 2 volt DC. It's pretty good. If I have that device to replace my something called what? The two fuse. You see the two fuse down there? The thing down there? It will be much safer to the speaker. I would highly suggestion, if we have amplifier, we put a lot of money, we put a lot of effort to restore that thing to a good quality, and we expect it to work in the next decade or 2 decades. Replace that, put it in a speaker protector. I suggest using the one with better quality of the relay. This thing can handle more power and maybe can last longer. Now with the duct tape in place, I keep this thing in the amplifier. I will go ahead to fix the amplifier and come back to double check if that power ground loop is hitting or not. If not, we'll finalize this installation to mount this guy to over here, this section. Sure, we need to make it look nice, to have isolation and everything here, and wire the wire through here. Look very nice, look like it's original, to be able to finish this installation. Now the amplifier is fixed. Let's check the output voltage of the speaker, the amplifier output. This is the right channel. It's about 1 millivolt, 3 millivolt. Check the left channel, 3 millivolt, 2 point something millivolt. Yep. Now the amplifier output is okay. Let's double check what the protection doing. Let's turn off the amplifier. Now let me move this thing to the other. Now let's check how the protect module working. Everything's on, and the power on. Yep, the green light's on. Turn it off. Now let's test the protector to see how it works. If I turn on the power, the blue light will light up. Let's see. Speakers in. Drop. Connect again. I connect analog voltmeter to the speaker output, to the amplifier output. Let's take a look why the protector cut off after it connected. That is because this amplifier, it has a, I think it's about 6 second delay. After 6 seconds, this amplifier, they have a delay circuit to provide the voltage to the amplifier, the power output section. So after that 6 seconds, the amplifier just start to kick in. When it first kick in, the output voltage is not stable yet. If the output voltage is not stable and the DC put into the speaker output is more than 2 volt, and this device, this module detect that 2 volt, immediately cut the thing off. So that's why after the green light on, the speaker already connected, but amplifier is not ready yet. After 6 seconds, this amplifier start to function, but the output voltage is not stabilized. And then this module cut the amplifier to the speaker connection again to wait until this amplifier stabilized to 1.7 volt, and then it will connect it to that. But this kind of the action is not normal. We're not supposed to have a speaker protector in the amplifier. 3 seconds it kick in, and 6 seconds and kick out, and wait about 5-6 seconds to kick in again. That's not normal. Go back to the UPC1237. See that 7 pin 7. There's 56K and 33 μ capacitor here. This is the thing to delay the first kick in of the relay. So if we change this combination, we can control when this pin 6 can start to provide the voltage to the relay to be able to kick in. In the default setting, they set this thing to 3 seconds. But as we know, this amplifier have longer than that. It's about 6 seconds. By that, we need to increase this thing, make this capacitor bigger, have more time to charge, and then delay the output to kick in this relay. As long as we can make this time longer than the amplifier ready time, we can avoid that drop and reconnect issue. Let's try to increase this capacitor to see what we can do for that. I have another circuit here. Pin 1 this side. So pin 1 here, pin 7 going to be here. So let's see which one. So this is the capacitor for the time delay. Turn this side, this one. I have parallel run over the 100 megafarad capacitor to the original one. The original one is 47 megafarad. Now I add 100, that is going to be 147 with parallel. Let's try to see. Okay, after we connect that 100 megafarad to the board, we definitely solve the connect and disconnect issue again. But the problem is what? The delay time will be more than 10 seconds. And why we have that much time delay? That's because when the amplifier kick in, the voltage drop up to more than 2 volt, and then the UPC block the relay to kick in until the voltage slowly drop to the acceptable, definitely under the 1 volt, and then the UPC will allow the number 6 to give the voltage to the RL, the relay, to kick the relay to connect to that speaker, and the speaker start to play the real like sound. Actually, after the amplifier kick in to the voltage drop to 1 volt, to be able to get that UPC accept that voltage, it take about like 3-4 seconds over there. If we want to reduce that 3-4 seconds, we need to do something. Why that 3-4 seconds over there? Why, if we don't have that protector with direct connect to the speaker, it will only have a pop, and then everything's fine. Sure, the pop is not fun, right? But the thing is, after the pop, the sound will be stable. The issue is over here. Before the relay get kicked in, and this connector of the relay will connect to an empty pin. This pin is nothing connect in the board. There's nothing connect in the board. It's about this pin. It's this pin. It is empty. It's not connected anywhere. So by that, this amplifier output have 2 volt here. That 2 volt got nowhere to go. You see that this thing's cut off. Got nowhere to go. So you have to go to the other path to release the that 2 volt down to 1 volt. But because this thing is km, 56 km over here, and also the other part is also very higher impedance. So you won't be able to release this 2 volt very quick. To solve that issue is what? Let me put that 2 volt here. Let's say 2 volt here, right? And we have 2 volt here. Yeah, that 2 volt. We want to release the 2 volt after the speaker just kick in. What we can do is what? Because the relay default is connected to an empty pin. If you connect that empty pin with a 16 ohm, maybe 16 ohm, maybe 32 ohm, 24 ohm, doesn't matter, but connect a small resistance to the ground. Then by default, this amplifier will be connected to that resistor to ground, because the resistor is 16 ohm, greater than the 8 ohm of the speaker. So this is safe. This is safe. And then once this kick in, 2 volt will quickly release through this dummy low to the ground, and the voltage quickly drop to the 1 volt. And then number 2 can immediately kick in to give number 6 the voltage to drive this relay, and this relay will move this pin to this 8 ohm speaker. Move this to here, 8 ohm speaker. By this way, this dummy low will be okay to put in here, because after this move, it's just empty here. You won't be able to connect to anything. So by this way, we can solve the issue is the delay time is too long. It's not critical in the direct connect OCL amplifier, but I have one of the other amplifier is net 710. That is using the OCL. It have a coupling capacitor is 47 megafarad, and that have really issue with this release time, because what, that capacitor is so big. If you want to build up that capacitor to a stable voltage, I tried that more than 15 seconds. So with the speaker open, it's gonna take more than 15 seconds to charge that 4700 megafarad capacitor to be able to stabilize the output. But if we don't have that protector, there's a huge pop. It's a huge pop to the speaker. Oh, it's very, very scary. So you cannot avoid that, because you have to charge that capacitor. So you always build up by the time. So you get a huge pop to the speaker. By this way, you'll be able to solve the long delay time and the pop to the speaker, both. I have a such case in my OTL. But there is one thing here we need to also take in consideration. You know what? What happened? This thing broken. What happened? This relay dead. Even the number 6 provide the voltage to that. It just doesn't work. It's just not moving this to here. So it keep connect this thing to here. What happened? So you're gonna turn on the volume, you can turn on the music, everything. If you have a 100 watt amplifier, you turn the music on, all the power gonna go from here to this 16 ohm resistor. If you put a 1/4 watt resistor over there. This thing gonna immediately get burned down. Yeah, in my 710, the net 710, I put in a 47 ohm resistor here, and that 47 ohm is a 5 watt. So even I get something problem, and this thing still be able to hold on for a while. And also I am careful to not put this thing close to anything can be make fire, can be overheat to make fire. So yeah, there's a lot of things. When you didn't do that, you never know that. When you really work on that, you find out something unexpected, and you find a solution to solve that. The amplifier is working. The protect module is also working. I will leave this amplifier work overnight, not even say overnight. I will leave it working. I'm not watch it. Now the power is go to this speaker, these two speakers. I have a testing here. You see this is speaker. I will turn this thing up. After I turn it up, the speaker is disconnected. I will have 2 ohm 100 watt down below here to connect to the amplifier. I can turn on the volume without make a lot of noise to the neighbor. You see that? I have a mu meter over there. Right now I am pushing this meter to, let me turn it a little bit up. Let's say about 20 volt. About 20 volt. I have a chart on the this wire is over here. I have a chart is over there to see what is the voltage I have. If I say 20 volt, I can crank it a little bit up to 25. Yeah, it's about 20 volt right now. 25. Once I have the 25, I believe this amplifier right now is in 10 watt output, 10 to 15 watt output, because it's music, it's not the sound wave, so we don't know exactly what wattage it is. Let's go back to the meter. See that it up down, right? So by this way, I can just put in almost full power to that thing to run in this testing device. I don't need to watch it. I also have a switch here. I can listen to the speaker. So by that, I know the speaker is still working, the music is still working, and also the quality of the music is okay. When you hear that, you don't hear the overpower, that kind of cut off sound. But when I leave, I turn it lower to not like make a lot of noise at the late night. Yeah, this is kind of a stop. I will leave this amplifier to run here until tomorrow night. If I have time, I come back here and I will take a look everything okay. This is pretty much the thing for the speaker protect module.